Okay, let's give you guys some practice. So, imagine you've got a spring here. This is a spring. You're told that, well, it's always true that the extension of the spring is directly proportional to the mass that you put on the end of the spring. So, if you put no mass on here, zero here, then the extension is zero. It doesn't extend. But if you put a mass at the end of the spring, the spring here will extend. The thing is the bigger the bigger the mass here, the bigger the extension. The smaller the mass, the smaller the extension. So you can say that the extension of a spring is directly proportional to its mass, to the mass that you put on the end of it. Okay, so this bit here is the extension. Okay, so this here you just have to accept, and it's true with pretty much all springs. So yeah, so the extension of the spring is directly proportional to the mass you put on at the end. Now the question is, hang on, the question is find the relationship between extension and mass. What that means is, well, if you're told that if you're told that the extension is proportional to the mass, you can pretty much draw a graph like this. The extension here, extension, and the mass down here. Okay, you can draw them the graph like this, and because this is a directly proportional relationship, it's going to be a straight line. Okay, so it could be a steep line, and it depends on the spring, the quality of the spring, or it could be a shallow line like this. The gradient depends on the spring. Well, when you're asked to find the relationship between extension and mass, what I'm asking is pretty much find the equation that connects to y, which in this case is the extension. It's going to be mx plus c. C here will be 0 because so we can forget about the c. It's a matter of you finding out the equation here, y equals mx or y equals kx. Okay. Well, when you're asked to find the relationship between extension and the spring, it's pretty much me asking you to find this equation here. Okay, and once you've got this equation here, then you can find out find out what the extension would be if I put a mass of this much on the end of the spring. So once you've got your equation here, you can put this into here and then find out the extension. And then question 3, find out find out the mass needed to produce an extension of 9 centimeters. So again, once you've got this equation, you can figure that out. Okay. So anyway, press pause and have a go. Answer these 3 questions. So press pause and have a go. Okay, because you're told that extension is directly proportional to mass, you can pretty much draw the graph like this. It's going to be a straight line. When you put 200 on here, let's say 200 is here. Okay. When you put so here this will be mass. This will be extension. And extension is in centimeters, and mass here will be, let's say, in grams. Okay. So when you're at the 200 mark here, it will have an extension of 5 centimeters. So this is pretty much, well, it's going to be a straight line here. So it's a matter of you finding out the gradient. But let's say you're not going to draw this graph. Let's just say, well, when you're told that extension is directly proportional to mass, you know it's going to be a straight line. Well, if it's a straight line, it's going to be y equals mx plus c. Well, it's a straight line going through the origin. So let's forget about the c. Okay, so it boils down to y equals mx, just y equals mx. Okay, now initially you're told that 200 an extension of 5 centimeters. So let's put the 200 into this into the, well, don't forget, this is your x here. This is the x-axis, and mass is along the x-axis. So let's put the mass into this x here, and put the 5 into the y here, and then we can find out the m. Okay, so hang on, let me get some space. So it's going to be y equals mx, and remember we're putting 200 into the x, so it's going to be like this: 200 m, where m's a gradient. Okay, y will, the extension will be 5. So it's just a matter of finding m now. So divide both sides by 200. So 5 over 200 equals m. So now let's divide top and bottom here by 5, just to tidy this up. So this will be 1, this will be 40. So it's going to be 1 over 40. So m equals 1 over 40. Now that you've got m, so you know the equation is going to be y equals 1 over 40 x. Okay, x happens to be the mass in this case. Now, so find the relationship between extension and mass. So you could say extension here, extension equals 1 over 40 times the mass. Let's just call it m here. Okay, so let's call it mass, because this m, if we were just to call it m, then it might conflict with this gradient, the m of the gradient. Okay, so this here will be your relationship here. Okay, so question 2, what will be the extension if I put a mass of this much on? So if I put this much on, then put this into the mass here to find out the extension. Okay, so hang on. So it will be 1 over 40 times, well, remember, once you've got the relationship here, you can just put the mass into the formula here. So it will be times 387 here. So calculator, hang on, calculator. So it will be 387 divided by 40. So the extension will be 9.675 centimeters. Okay. And question 3 is what mass is needed to produce an extension of 9 centimeters. Okay, so our formulas are y equals 1 over 40 x here. So well, what mass is needed to produce an extension of 9 centimeters here? This 9 centimeters here, put it into the y here. So it will be 9 goes into the y, and then 1 over 40 times x here. This gets multiplied to the top. So hang on. So it will be this. It will be this over 40. So now times both sides by 40. That will give you x. So that will be 360 equals x. So we will need 360 grams in order to create an extension of 9 centimeters. Okay.